This is section 6.5, Determinants and Kramer's rule. We are going to learn a new method for solving a system of equations. Okay? The first thing we have to talk about are determinants in general. Okay? So if we have a matrix that looks like this, where A1, our A's here are basically, the coefficients of our x values, the coefficient of our y values. So if we have a matrix like this, notice that these are squared off brackets. That's a matrix. Notice right here that they are straight lines. They do not have the lines across the top. These are just straight, kind of like an absolute value. This is a determinant. I'm often asked, how do I know that I'm supposed to calculate a determinant? And that's exactly how. If it has the little brackets on it, it's just a matrix. If it's straight lines without the little brackets, you're being asked to calculate a determinant. Okay? Now, how do we calculate a determinant? I know it looks bad with this A1, A2 stuff right here, but it's really quite easy. You're going to take these two values, you're going to go on a diagonal, and you're going to multiply them together. A1 times B2. And then you're going to come back in the other direction. You're going to subtract, and then you multiply these two together. B1 times A2. You're going to get just a number as a determinant. Okay, so let's start off. I want to calculate this determinant. The first thing I'm going to do is I'm going to multiply 4 times 6, and I'm going to write out every step here so that you have it in your notes. 4 times 6 minus, it's always a minus there. Now multiply these two together. 8 times 5. And by the way, it does not matter whether you do 4 times 6 or 6 times 4, as long as you're multiplying on the diagonals. This would be 24 minus 40. And so your answer here is negative 16. Now, I know you don't know why you would want to do this at this point, but that's okay. We just have to learn how to do the calculations. So you multiply on this diagonal, and then you multiply on this diagonal, and you subtract. You do this one minus this one. Okay, so you're going to have to deal with fraction sum. So let's find the determinant here. Notice the straight lines. Okay, so I'm going to multiply here, and then I'm going to subtract and multiply here. We're going to be very careful with our signs. This is equal to 1/5 times 5 minus 1/6 times negative 6. 1/5 times 5 is 1, minus 1/6 times negative 6 is negative 1. So what I have here is 1 plus 1, so this determinant is equal to 2. Okay, so now that we know how to calculate a 2 by 2 determinant, we're going to talk about how to use it in Kramer's rule in order to solve a system of equations. Okay, so if you look right here, we have just a system, A1, A2, these are the coefficients of our x's, B1, B2, coefficients of our y's, C1, C2, these are the answers. These are like the equal part. If we were doing an augmented matrix, this would be our first column, second, and this would be the augmented part. Okay, to solve using Kramer's rule, and this is really kind of nice because it ends up being simply arithmetic, multiply, subtract, okay? We're going to have to calculate 3 different determinants. Okay, the first determinant, D, I'm going to start off by writing this one down here. All you do is you take your A values and your B values. We do not include our C values in just D. So this D determinant is going to be equal to 2, 1, 1, negative 1. Okay, so let's calculate this. I have 2 times negative 1 minus 1 times 1. So this is negative 2 minus 1, which gives me my D value as negative 3. Okay, now we need to calculate dx. And let's see what it is here. We've got to build a new determinant. If you look at what they did here, our y values are the same, but our x values are different. What goes in the x column is different. C1 and C2, these are our answers. So basically what we're doing every time, to find dx, we are going to replace the x column with our answers. Okay? So instead of doing 2 and 1, I'm going to do 3 and 3 right here. So I calculate 3, 3, 1, negative 1. Okay. Now multiply here, 3 times negative 1 minus 3 times 1. So this is negative 3 minus 3, and I get a negative 6. Okay, so from our original one, I covered up our x coefficients with the answers, which happen to be 3 and 3. Okay, now to find dy, we do the same thing, essentially. We're going to keep our x values showing, but we're going to cover up our y values with our solutions. So I end up calculating this determinant instead. So my x's are the same, 2 and 1, and then I have 3 and 3. Okay. Multiply 2 times 3 minus 3 times 1. This gives me 6 minus 3, which is equal to 3. Now we have our answers here. Really quickly, to find our x coordinate, you just divide dx by d. So my x value, dx divided by d, would be negative 6 divided by negative 3, which is positive 2. My y values, I do the similar thing. I divide dy by d, which gives me 3 divided by negative 3, so that is a negative 1. Our solution here is going to be the point 2, negative 1. Okay?